Welcome to the DIY Honda Garage channel. The DTC P0400 indicates that there is an EGR system leak detected in the Honda Civic models from 2006 to 2011. EGR stands for exhaust gas recirculation, which is a crucial emission control system responsible for reducing nitrogen oxide (NOx) emissions. The system recirculates a portion of the exhaust gas back to the engine's intake manifold, which helps lower combustion temperatures and subsequently reduce the amount of NOx produced. If there's a leak, it can lead to poor engine performance, increased emissions, and possible failure to pass emissions testing. In these models, the EGR valve, EGR pipe, and associated connections are pivotal in the system's functioning. Errors can arise from a variety of mechanical failures, obstructed pathways, or electronic issues affecting the EGR system's operation. The EGR system components essential for operation include the EGR valve and the EGR pipe. The EGR valve is responsible for regulating the amount of exhaust gas that gets recirculated into the intake manifold and is generally located in the engine compartment, making it accessible for inspection and replacement. The EGR pipe connects the EGR valve to the intake manifold, ensuring proper flow of exhaust gases. A leak in the EGR pipe can compromise the system's effectiveness, leading to the DTC P0400 error. Inspecting these components is crucial before proceeding with further diagnosis. Knowing their locations simplifies the troubleshooting process and helps ensure all potential areas of fault are covered comprehensively. The causes for the DTC P0400 error may stem from several factors. A loose or damaged EGR pipe is a common issue that can lead to significant leaks within the system, affecting its efficiency. Additionally, a faulty EGR valve may fail to control exhaust gas flow correctly, resulting in performance issues. Electrical connection problems, such as poor or loose terminals at the EGR valve and the engine control module, ECM, or powertrain control module, PCM, can also trigger this error. Each of these potential causes must be carefully evaluated during troubleshooting to isolate and rectify the issue effectively. Keeping these causes in mind guides the mechanic toward the most likely source of failure within the EGR system. Among the symptoms associated with DTC P0400 are decreased engine performance, increased emissions, and illumination of the check engine light on the dashboard. Drivers may notice their vehicle lacking power, struggling to accelerate, or experiencing rough idling due to inefficient exhaust gas recirculation. Additionally, the vehicle may produce higher levels of harmful emissions, raising concerns about environmental regulations and potential penalties during emissions testing. The check engine light serves as an initial indicator, alerting the driver to the potential underlying issue with the EGR system. Recognizing these symptoms early can help prevent further mechanical damage and ensure continued compliance with emission standards. The first step in troubleshooting DTC P0400 is to check the EGR pipe for any signs of damage or looseness. The EGR pipe is critical as it influences how exhaust gases circulate back into the engine. If it's damaged or improperly connected, it can result in a substantial leak, triggering the DTC P0400 error. If the EGR pipe is found to be in good condition, you will proceed to step 2. Conversely, if any imperfections are noted in the EGR pipe, corrective actions such as tightening or replacing the pipe must be undertaken before advancing to the next steps. This initial inspection establishes the foundation for further diagnosis, ensuring that you are not addressing issues in the larger system that are rooted in a simple misconnection. In this step, the engine must be started and the RPM held at 3,000 without any load on the engine, such as automatic transmission in park or neutral, or manual transmission in neutral. It's crucial to maintain this RPM until the radiator fan starts running, which indicates the engine has reached operating temperature. After the fan activates, allow the vehicle to idle. This procedure helps to ensure that the EGR and related systems are running under conditions that could replicate the circumstances in which the DTC P0400 was triggered. Keeping the engine in this elevated RPM state allows the technician to assess the EGR's functionality while simulating the operational conditions under which leaks often manifest. This step involves taking the vehicle for a test drive under specific conditions to accurately assess the EGR system. The engine coolant temperature should be above 158 degrees Fahrenheit or 70 degrees Celsius, with the automatic transmission in drive and manual transmission in fourth gear. While driving, maintain a vehicle speed of 25 miles per hour for at least 5 minutes, followed by a steady speed of 32 miles per hour for another 5 minutes using cruise control. This method ensures the EGR system operates under typical conditions and allows any potential failures to emerge. Observing these parameters is fundamental, as they can help replicate the actual situations leading to the original diagnostic error, ultimately guiding the mechanic in identifying subsequent issues related to the system. At this stage, you will monitor the onboard diagnostic (OBD) status for DTC P0400 within the DTCs menu using the Honda Diagnostic System HDS. If the status screen indicates failed, it confirms the presence of the problem in the EGR system. If it indicates passed, the system may be functioning correctly at this time, and it may indicate an intermittent failure. In such cases, next you should check for poor connections or loose terminals at both the EGR valve and the ECM/PCM. On the other hand, if it shows not completed, you should return to Step 3 and recheck conditions to ensure that everything is completed adequately before moving forward. Monitoring the OBD status provides critical real-time feedback on the system's health, thus guiding your troubleshooting choices. In this step, you will turn the ignition switch to the lock position, which is vital for ensuring that the electrical systems are fully powered down before performing any repairs. This practice is crucial for safety reasons, preventing electrical shocks and protecting the vehicle's accessories. Once the ignition is locked, you will then prepare to replace the EGR valve, as it was determined that the system is failing to operate correctly based on the status check. Replacing the EGR valve is often a necessary solution for persistent DTC error codes related to the EGR system. This procedure typically involves removing the faulty valve, cleaning the mating surfaces, and then installing the new valve following all manufacturer guidelines to ensure a seamless operation of the new component. After replacing the EGR valve, turn the ignition switch to the on position, which powers up the vehicle's electrical systems without starting the engine. It's essential to reset the engine control module, ECM, or powertrain control module, PCM, using the Honda Diagnostic System. This step is crucial because it clears any stored trouble codes from the previous system faults, providing a clean slate for any new diagnostic tests. Resetting the ECM or PCM also allows the newly installed EGR valve to be recognized by the system, ensuring optimal function moving forward. Performing this reset is a necessary part of the process, allowing both the technician and the vehicle to operate under the latest configuration without the interference of old error codes. In this step, it is essential to perform the ECM-PCM idle learn procedure. This procedure is necessary to recalibrate the engine's idle speed and fuel delivery characteristics after any major repairs have been made to the EGR system. The idle learn process ensures that the ECM-PCM accurately understands the new operating conditions and configurations particular to the newly installed EGR valve. Without this adjustment, the engine may run erratically or inefficiently. Upon completing the idle learn procedure, you're now prepared for the subsequent test drive to validate that the repair was successful. This step is critical in confirming that the newly installed components are functioning harmoniously with the existing engine management strategies. Here, you will conduct another test drive under the same conditions specified in previous steps of the troubleshooting process. It is vital, once more, to ensure that the engine coolant temperature exceeds 158 degrees Fahrenheit or 70 degrees Celsius, with the automatic transmission in drive and the manual transmission in fourth gear. Maintain a speed of 25 miles per hour for a minimum of 5 minutes, followed by maintaining a speed of 32 miles per hour for 5 more minutes while using cruise control. This repetition is necessary to assess how the new EGR valve and any connections made during the repair are performing. Observing the vehicle's behavior during this driving test will help identify whether the earlier DTC P0400 error has been resolved, ensuring that the repairs made have successfully addressed the underlying problems. After the completion of the test drive, the next step involves checking for any pending or confirmed DTCs with the Honda Diagnostics system. This check will determine if DTC P0400 is still present after the repairs have been made. If DTC P0400 is appearing again, it indicates that the problem hasn't been fully rectified and requires further inspection into the EGR valve connections and wiring at the ECM-PCM. These areas are often where issues can recur if not thoroughly addressed. On the flip side, if DTC P0400 is not indicated, you can move on to the final troubleshooting measures, signifying that previous issues may have been effectively addressed and resolved. In this concluding troubleshooting step, you will monitor the onboard diagnostic (OBD) status for DTC P0400 again in the Honda Diagnostics System menu. An indication of passed confirms that the EGR system is functioning correctly after repair and that the DTC P0400 error has been resolved. If this is the case, it means that the inspection process has worked and the vehicle is fully functional after addressing all concerned issues. However, if the status indicates failed, it suggests that there are lingering issues that necessitate another round of inspection, likely regarding the EGR connections or valve functionality. If not completed appears, this may require you to go back and repeat the test drive conditions to ensure the ECM-PCM has fully completed its assessments and reconciliations with the new component installations. In this phase of the diagnostic procedure, it is crucial to confirm that the EGR system is operating properly and that there are no further trouble codes present. This involves a final examination of all repairs and ensuring that all connections have been made securely. The EGR valve should function without any hitches, and the EGR pipe should be intact with no signs of leaks. This verification is essential to assure the driver that the vehicle meets regulatory emission standards and operates efficiently. Beyond visual and electronic checks, one last test drive is often recommended to validate the repair success fully. This stage acts as the ultimate indicator that the entire repair process has been effective and that the vehicle is back to its optimal functional state. For effective preventive maintenance regarding the EGR system and avoiding future occurrences of DTC P0400, routine inspections play a crucial role. Regularly checking the EGR valve and the EGR pipe for signs of wear and tear can help identify potential issues before they escalate into more significant problems. Furthermore, keeping electrical connections clean and secure ensures reliable performance of the EGR system components. Scheduling routine maintenance intervals can include cleaning or replacing the EGR valve and verifying that the system is functioning correctly. This proactive approach helps maintain the vehicle's emission standards and extends the overall lifespan of the EGR system while ensuring optimal engine performance throughout the vehicle's lifespan. In conclusion, the DTC P0400 error highlights the importance of a properly functioning EGR system to ensure a vehicle's performance and compliance with emission standards. The EGR valve and pipe are integral components of the system, and understanding their roles is crucial for effective troubleshooting and repair. Thorough steps within the troubleshooting process guide mechanics through systematic checks to isolate and rectify any issues leading to this error code. Following a successful repair, routine preventive maintenance is encouraged to sustain the EGR system's condition and prevent similar future issues. By staying proactive and informed, vehicle owners can contribute to more reliable performance and adherence to environmental regulations. Please like and subscribe to the channel. See you next time.